All right, good afternoon. So today, before we get started, I wanted to take just a moment and hop over to our Moodle here so that we can chat just a smidge about the upcoming midterm. So you may have seen this announcement, you may not have. There it goes. Actually on the right class this time. I did it this morning and I was looking at the wrong class. So our second midterm is coming up next Monday, so November 1st. And because last time we got moved online just in time for the midterm, and now we're back in person again, I just wanted to go through the details because we haven't actually had an in-person midterm yet due to that switch online. So we're going to be having the exam here in class during the normal 50-minute period. So you'll show up at the usual time, you will write here during the usual time, and then you will head out when you're finished. Because I'm less concerned about time crunch and sort of people having access to Google and stuff with an in-person version of the exam, I'm only having 35 multiple choice questions, still 5 short answer questions, but just a little bit fewer questions total. So you'll have a little bit more time to muse over your responses. So still that same concept of multiple choice and short answer, getting you to show that you understand concepts a lot more than just that you can memorize definitions and stuff like that. It's going to cover chapters 4, 5, and 6. So basically everything since the first midterm has finished. So it's going to include up until this Friday, but my intention is that we should be finishing up most of the new content by Wednesday, and that'll leave us with Friday for me to talk a little bit about sort of hands-on applications of operant conditioning using chickadees, as well as maybe when we have some time at the end, we can open the floor up for questions and stuff like that. So that way we will still have class on Friday, but it won't be anything new that you're going to need to know for the exam on Monday, just to give you a little bit more time to learn up on stuff. Oh, and then the last one I wanted to specify was for in-person and open book. So in this case, you can have anything that's hard copy. So physical notes, your textbook, anything that you can hold in your hands that is not a computer or electronic device. Just because not everyone has access to a laptop that they can bring to class. So I'm trying to keep things fair with that. And so my encouragement is actually, instead of focusing on, say, printing out notes or having a physical hard copy of your textbook if you don't have one already, I'd suggest that while you're studying, maybe focus on making like a cheat sheet, 1 or 2 pages of the really important concepts that you want to make sure that you don't forget, just so that you have something quick and easy to reference. Because I find that it's one of the best ways to study, picking out the most important concepts and putting them all together in one place. And B, we're not going to have a whole ton of time to go flipping through stuff and looking everything up. So having it all on 1 or 2 pages is probably for the best anyways. But that's my recommendation. If you want to have your full textbook with a bunch of sticky notes and certain areas easy to get to, you are welcome to do that. But that's how we're doing open book for this, is anything on paper. And I think that was everything I wanted to say for that. This is all. You should have gotten a notification or email that'll direct you to this, and it's up on Moodle. But you can let me know if I missed anything. Anybody have any questions right off the bat? Not yet? Okay, cool. Well, then we will leave that there. And I'm going to hop over here, and there we go. And doing that. Perfect. All right. So last time we finished up talking about our classical or Pavlovian conditioning, and now we get to move on into instrumental or operant conditioning. And so the first of our types of learning that we had talked about was our event alone learning. That was habituation, where we had a single stimulus and we learned something about that. We changed our behavior from the repeated presentation of the same stimulus. And then we had our event learning for classical conditioning, where we associated two stimuli. We learned to link them together and learn something about them in conjunction. And now we have behavior event learning. And this is going to be where there's some kind of behavior or action, and there's some kind of follow-up stimulus or outcome. And we're going to learn something about how that behavior relates to that outcome, which is why it's named as it is. And this will start making more sense as we get through the major concepts involved here. But starting off, let's go with our base definition. So operant conditioning is learning that is controlled by the consequences of an organism's behavior. So we're going to see a lot of sort of this stimulus response outcome idea. So we have an original stimulus, something in our environment that tells us that we could make a particular response. And then we have the response or the behavior that we will perform. And then that behavior is going to lead to some kind of outcome. Maybe something good happens, maybe something bad happens. And we're going to talk about what we learn based on sort of all of these different aspects here. And so again, there's a lot of terminology here. I actually find the operant conditioning section just a little bit more manageable than classical conditioning for whatever reason, but hopefully it is for you as well. So we're going to come back to this image quite a few times throughout. But we're going to start off with our first famous individual, and this is Edward Thorndike, who was well known for his law of effect. So you might remember Thorndike as one of our behaviorists who was focusing in on the fact that our behavior is controlled by our environment and that we learn by interacting with things in our environment. So that's where he started from. And so the law of effect states that if a response in the presence of a stimulus is followed by a satisfying state of affairs, the bond between stimulus and response will be strengthened. So if we come back here, so if we're saying, okay, again, wrong direction. So if we say, okay, so in the presence of a particular stimulus, a certain behavior or response leads to a good outcome, then we are strengthening the association or the link between our stimulus and response. All that means is that if we do a particular behavior in a particular situation and we get something good from it, we're going to do that behavior more often the next time we're in that particular situation. So maybe your mom's in the kitchen and the kitchen's a little bit messy and you wipe down the counter. And she's very happy, so she gives you a bag of cookies. That would be a good outcome. So the next time you're in the kitchen with your mother and the counter's messy, maybe you're a little bit more likely to wipe down the counter because you might get cookies again. That would be that sort of satisfying outcome leading to a behavior being more likely to occur in the future. So we could also say that that process is stamping in the relationship between that particular stimulus or that particular situation and the response that you made. We can also have the opposite of this, though. If we have a sort of a situation and it leads to a bad outcome. So let's stick with being around a parent, and maybe this time you swear in front of a parent. And if they're anything like my parents, then you'd get in a lot of trouble. So our situation, our initial stimulus is the presence of your parents. The action is swearing, that response is swearing, and the outcome is a thorough scolding. So that's a bad outcome. So that would be something that is uncomfortable or dissatisfying. So maybe we would be less likely to swear in front of our parents in the future. So we would stamp out that relationship. So whenever they're around, we avoid that behavior in the future. So we can have sort of stronger or weaker associations that lead to something happening more or less.
I don't know if this is right, but so how could you tell the difference between this and classical conditioning, as since we talked about, if you ring a bell, the dog would know food. So wouldn't that be like he would know what happens after? So every time you ring the bell, he would want food.
So there is a whole slide on telling them apart, but our sort of quick and dirty way to do it is that classical conditioning is something that's going to happen without a lot of conscious thought. As much as we talk about sort of they've learned this association, the dog doesn't decide to salivate, right? It just happens. Whereas you would be sort of evaluating whether you swear or not, or whether you wipe the counter or not. So this is when it's not so much that you're sort of linking two concepts together automatically. This is where you are consciously making a behavioral response. There can be a little bit of bleed over between the two, and we'll actually look at something that involves both classical and operant sort of together. But we're going to focus on the examples where it's like you choose to do a behavior or it happens automatically. And that's how we'll distinguish. Okay, and so Thorndike, with his sort of this idea, came about because of a lot of research that he was doing with puzzle boxes. And so this is an example of one of those puzzle boxes. So he had hungry cats who would be placed in these strange box-like contraptions that had very complicated escape routes that he had designed. So he called these puzzles because the cats had to figure out how to overcome them in order to get out of the box. And so the idea was that if they're hungry, then they are highly motivated to get out, especially when he would place milk or food outside. So then not only do they not want to be in the box, but they'd like to get access to that food, just applying a little bit of motivation there. And so the reason for this setup is actually because Thorndike was trying to tell the difference between two broad types of learning. And I'm going to be hopping back and forth between two slides here. So this slide is very similar to what we had just seen in terms of the graph where we saw our puzzle box, but this is showing sort of our idealized data. And so on this graph along the bottom, we have successive trials, which is just the number of times the cat's been in the box. So that's our measure of time, as almost always in this course. Then our y-axis is time to solution, or how long it takes the cat to escape. The higher they are on that axis, the longer they're in the box. So the lower on that axis, the better they're doing, the more they've learned. And so we're trying to tell the difference between those two types of learning. The first is what people thought was going on, and this is insightful or non-incremental improvement. So you would, if we look at our sort of triangle line, we see that the cats would, in that situation, spend a lot of time in the box. They'd spend a lot of time in the box. And then all of a sudden, they'd have a moment of insight, kind of like an aha moment, where it finally occurs to them how to solve the problem. And as soon as that insight moment passed, they would then spend very, very little time in the box. So they would go from not being able to escape or spending a really long time trying to escape to figuring it out and then getting out quickly from that point onward. So if that's what our data looked like, taking a long time and then a sudden switch to solving it very quickly, that would be evidence for insight, for figuring it out and just sort of working it out internally. But what Thorndike thought was going on was this idea of incremental improvement, or sort of trial and error solutions, where at the beginning, the cats would take a really, really long time to get out of the box. So starting the same, our circle line, though, doesn't stay at the top for long. Gradually, the cats would figure out some actions that led to a good outcome, that would lead to them escaping the box. So slowly, they'd be doing more of those actions that led to them getting out of the box. And by learning which ones to do more frequently, they'd get out of the box a lot faster. So we'd see gradual improvement until eventually the cats get out of the box fairly consistently because of those sort of baby steps, that incremental or trial and error learning. And that's what Thorndike was hoping to see, to disprove the existence of insight, especially in non-human animals. And so if we hop back to this diagram here, that's going to be sort of realistic data. So we still have our trials or time on the X and the length of time to escape on the Y. And it's a little bit messier because it's real data. So we see lots of ups and downs. Some trials took a really long time, some not that long at all. But we see that in general, they took a little bit longer to figure it out at the beginning, and they were much faster at it on average towards the end. And so he had more evidence for that trial and error learning or that incremental improvement in learning, which supported his law of effect, which is why we care about the law of effect to begin with. And if you're interested in a little bit more of how these puzzle boxes worked, or if you just want to hear somebody else explain it in slightly different words, there's a YouTube video there. I usually use that sort of in class if people are confused, but I find that it's mostly good as just sort of an extra resource, possibly because I'm explaining it a little bit better now. Okay, so from Thorndike, we actually ended up progressing. And I guess before we move on to Skinner, we should mention that during that stage, because Thorndike was using those puzzle boxes and the cats had to manipulate different sort of objects within, so they were using foot pedals and levers and all sorts of different things, at that point it was only called instrumental learning or instrumental conditioning because the cats were using instruments to escape, so pedals and levers and stuff like that. But eventually we sort of transitioned over because Skinner started talking about the operant process, and we'll specifically be looking at operants, which are actions that can be performed to lead to a particular outcome. So this is why operant conditioning sort of became more popular. So either term is technically correct, but they just have different sources. Okay, sort of the background of the words aside, Skinner is our next individual here, and we mentioned Skinner as a radical behaviorist. So Skinner was sort of fully behind the idea that everything that we learned came only from the environment. Not just that the environment played a critical role, but that the environment was the only thing that had a hand in our behavior. We only learned from experience with our environment, which is why radical was added there. So he took a pretty strong stance on this effect of our environment on our behavior. And we care about Skinner because he identified many key processes that take place during operant conditioning. He did extensive trials that let us pick apart what's going on at different stages of operant conditioning and led to most of the knowledge and terminology that associates with this field now. One of our biggest things we're going to care about right now, though, is the Skinner box or an operant chamber. I typically go with operant chamber just because that's what I've always called them when we've used them. But if you see Skinner box or Skinner chamber or operant box, they're all the same basic combination. But this is basically a fancy setup, kind of like the one on the screen here. And they're going to look a little bit different depending on what species you're using. Typically, you see them with rats or pigeons. I'm going to show you one with black-capped chickadees on Friday. You can have operant box setups for humans or whatever. There's all sorts of neat ways you can set it up, but they have the same basic controls, more or less. This one here has access to food and water. Water is usually free access. Food is usually controlled. And the reason for this is that food is one of the easiest outcomes that you can provide, where getting food is a good thing. So we tend to use food as our outcome for most of the behaviors. This comes with some things that need to be monitored, and this is more than you probably need to know, but I always have somebody asking questions, especially when it comes to ethics. Most of the time, if you work with a larger animal, like say a rat or a pigeon, they're only in the operant box for, say, an hour, hour and a half at a time. At least for pigeons, it's because they will eat so much in that time that they stop eating and they won't do any more trials for you. With pigeons, they're pretty easy to handle. You just sort of pick them up. They're larger than you might want them to be, but typically you can store them sort of head down in like a juice jug. So a pitcher that you would mix Kool-Aid in. The standard way to transport them is to put them in one of those jugs so that it holds their wings close to them so they can't get loose. It is not infallible. We have chased many a pigeon for other labs in the hallways, but it's kind of typical to see a couple of undergrads running around with 5 or 6 buckets of pigeons in the hallways. And so they don't mind. They're big enough and they're chill enough that you just sort of move them around. I work with chickadees, which are significantly smaller. So instead of like 900 grams, 12 grams. So chickadees have a tendency to keel over from stress. So we don't handle them very much. They also have really high metabolisms, which means that we could run them all day, every day. So we use that and leave them in the operant boxes for like weeks on end. We check on them twice a day, and we monitor their food levels so we know that they're not starving, and we'll give them extra food if they need it. But it's sort of a different setup. So we have different considerations depending on what species we work with. But it allows us to make sure that they're eating enough while also being motivated to continue participating. But I always have somebody who asks about how that works, because it's not necessarily clear that you only have them in the box for a short period of time. Yep.
Do you ever have a case for like a pigeon attack, like a pigeon attacked an undergrad student or something?
Fairly often. They can be aggressive. Like they're not going to do a lot of harm. Usually, like, we'll have protective gear and stuff. So if you have one, and you usually know by their band number which ones are jerks. So you'd be like, yes, that's C7. He needs gloves. So you'd put on a pair of gloves and then you're fine. For the most part, they tend not to be super aggressive. A lot of them, especially the ones that you enjoy working with, are pretty docile. So you can just sort of pick them up and go. Some of them are a little bit more aggressive than others. Ironically, the chickadees, which are significantly smaller, are a lot more aggressive. And they will attack and bite as much as they can, no matter what. The pigeons will kind of give up when they can't move their wings, but the chickadees will continue fighting. So it's always interesting. And that's why we don't handle them very much, because it stresses them out. So we only pick them up when they absolutely need to be, because we want them to be as chill and calm as possible. So it's interesting when you work with different species, the stuff you get used to. Yeah. Okay, so that was food and water. I didn't even finish the box. Tangents when I find stuff interesting. So the next stuff we care about are the fact that we have 2 lights there. So we have a green light and a red light. Those could be replaced with pretty much anything. Nowadays, we tend not to have sort of 2 stationary lights. That's very simplistic. Nowadays, you could just use like a touch screen. The pigeon operant boxes that I've seen just have large touch screens, and you can show images and you can sort of place buttons or targets for them to go for. But these would have sort of lights or buttons that they could target here. There's also a bar or a lever. So in this one, it would be a lever that the rat can press down on. With birds, it tends to be easier to have a button that they can peck. Same difference. It's an operant response. They push the button or press the lever or peck the screen, and we can record that. And then our recording is actually done with a recording device. And this was one of the biggest changes with these operant boxes, because at the time when this was done, we had to sit and monitor each animal individually. So with Thorndike and his cats, he'd put a cat in a puzzle box and he'd time it until the cat was out. So he'd have to do them one at a time, and he'd have to monitor each one. This would allow you to set up a rat in a box and walk away, because a recording device would register whenever the button was pressed, or whenever food was dispensed, or whatever you set it up to record. And nowadays, we can have really nice complex processes going on, where each box might be run by its own computer and have lots of interesting different setups in the background. But this is our most basic of those setups. So we could run multiple rets at a time. We could collect data on multiple different things, and we can get really nice, precise recordings of when a particular action happened relative to other factors. So when do they push the lever if the green light comes on versus the red light versus whatever. So lots of possibilities. And this is why this was so important for operant conditioning, because it allowed us to start picking apart all of the different stages and all of the different steps going on. Okay, so before we move too much further, we're going to introduce some alternate terms. So we had previously been using that idea of stimulus, response, outcome. We're now going to give them Skinner's sort of preferred terms, which are antecedent, behavior, consequence. There we go. So our antecedent would be something detectable in the environment that sets the occasion for us to respond. All this means is that there is a stimulus that lets us know that if we do a particular response, a particular outcome might happen. So when we had started at the beginning, we talked about our stimulus being our parents present. So an antecedent would also be your parents present. So you know that if you swear now, you're going to get in trouble. That would be an antecedent. So you'll sometimes see the terms used interchangeably. We can also talk about a behavior, also a response. And this is the activity that you perform, the activity that can be repeated and measured and has some kind of impact on our environment. You push a button, you peck a screen, you pull a lever, whatever you're doing, something that's monitorable. We might also call those operants if you wanted to refer to it by sort of a technical term, but most texts don't use that, at least not until you get into learning higher level stuff. And then the last thing, instead of outcome, we could talk about consequences. So this is same basic concept, but it is a stimulus or event that can either increase or decrease the probability of a behavior happening in the future. So the consequence might be that you get something good, you get something bad, you are more or less likely to behave that way again in the future. So these are just slightly different terms for the same basic concepts. So we can use any of these pretty much interchangeably, sort of in the vertical lines. But while we're talking about consequences, I wanted to take just a moment and talk about a concept called differential consequences. And we're going to see the term differential a couple of times. Differential just means different, effectively. So when we talk about differential consequences, we're saying that the consequences will be different depending on the actions that are performed to get to those consequences. So if we look at our first example here, our differential consequences, we have an experimenter who's working with a child. And so they would have, on the first line, their antecedent is to ask the child to give them a file. And then if a child's response or behavior is to pick up the file that they were asked for, then the consequence or outcome would be that the child gets a chip. If the experimenter asks for a clip and the child gives them a clip, then they get a different consequence, a different outcome. They'd get a cookie. And in both cases, they're snacks, they are good outcomes, and it's going to make the child more likely to perform the correct response in the future. But the fact that they each have their own distinct consequence actually aids in the learning process. Our example on the bottom is the same basic setup, except we have non-differential consequences. So no matter which thing they're asked for and which response they perform, as long as they do it right, they always get a raisin. So they get the same consequence. And for whatever reason, that makes it just a little bit harder for them to learn. So by having distinct chains of an antecedent, a response, and a consequence, and a separate antecedent, response, and consequence, we get easier and faster learning when there are those different lines. Whereas in the non-differential consequences, we have overlap in our consequences, and it makes them less distinct and harder to learn. So by having that distinction between them, we learn those processes faster. Okay. So the next thing I want to talk about are reinforcement contingencies. So we've kind of hand-waved a lot of these things that happen at the end, our consequences. So now we're going to get into what's specifically going on there. And to start with, we're going to define a contingency. And this is basically an if-then logic rule. So if you've ever done any kind of computer coding or anything that required logic, if-then rules are pretty standard. If not, then they're sort of just a basic setup of what should happen in a particular situation. So we could have the idea of, if you do this particular behavior, then that consequence will happen. We're setting up the rules. So when this happens, that is the outcome. So our contingency tells us what to expect. So here we're going to have a couple of different ways to divide this up. We're going to focus on sort of two axes. The first is the idea of reinforcement or punishment. So reinforcement is any outcome that strengthens the probability of a response. So when we use the example of a rat pressing a lever and getting food for that action, that would be reinforcement, because getting food is a good thing and it would make them more likely to press that lever in the future. Punishment is the opposite, any outcome that ends up weakening the probability of a response. So if the rat presses the lever and they don't get food, instead maybe the lights turn off and the box goes dark for a few seconds. That would be considered punishment, because it isn't a good outcome. The rat's not going to want to do that again because they don't want to sit there in the dark. So punishment is anything that happens that ends up making you less likely to do that same response again in the future. So that's one of our axes. So are we increasing or decreasing the probability of a response? Next, we can talk about something being positive or negative. Now, this is where we kind of have to acknowledge that we have some preconceived notions about certain terms. So even on this slide with punishment, when we think of punishment, we actually think of what we will come to call positive punishment. But punishment doesn't have to be as negative in connotation as we think of it as. So punishment is just any kind of outcome that weakens that probability of response. It doesn't say that it's sort of good or bad. We're just saying that it's weakening the probability of a response. And then when we talk about something being positive or negative, that is independent of whether it's reinforcement or punishment. And this will make more sense when we move on to the next slide. Once we start working it together and getting examples, this is probably the hardest part to grasp your heads around, but once you get there, you will be good. So when we talk about something being positive, we're just saying that we are adding something, we're adding a stimulus or an event, we're adding something as part of our consequence. If something is negative, then we're saying we're removing a stimulus, we're removing an event, we're taking something away. And so when we combine these, something can be positive or negative, reinforcement, or punishment. So that gives us 4 distinct options. And so I'm going to go through each of these with examples just to try and help out a little bit. So let's start with the simplest one. If we have positive reinforcement, positive means that we are applying a stimulus, we are sort of adding an event, and reinforcement means that this event or stimulus will increase the frequency of a desirable behavior. So positive reinforcement is like pushing that lever and getting food. You are receiving food, we are applying a stimulus, and it makes you more likely to press that lever in the future. Not too bad. What about positive punishment? So we're going to apply a stimulus that decreases the frequency of an undesirable behavior. So positive means we're adding something, but punishment means we're going to be less likely to do that behavior in the future. So we can go back to the example of swearing in front of a parent. If the parent yells or scolds you, we are adding an event. Being yelled at or scolded is something that's happening. And theoretically, it will decrease the likelihood that you do that behavior again. So it would fall under the category of positive punishment. So this is what people typically think of when they think of reinforcement and punishment. We frame things in terms of positive reinforcement and punishment, but we also have sort of a little bit more complex, bringing in that negative side of things. So this is a little bit harder to wrap your heads around, but hopefully with the examples it'll fit. So with negative, we're removing a stimulus, we're taking something away. So negative reinforcement is that we're taking something away that makes us more likely to do the behavior in the future. So imagine that you have a headache. That's something bad that's happening. That's an aversive stimulus. If you take Advil, your headache will go away. That's a good thing for the bad to leave. So we're taking away that bad stimulus, and you would probably be more likely to take Advil in the future so that you don't have a headache again. So it successfully got rid of that bad situation, so you're going to do it more in the future. That would be negative reinforcement. And then for negative punishment, we are removing something that would decrease the frequency of an undesirable behavior in the future. So if a child throws a toy, and they are not supposed to throw toys. So maybe you take away that toy. So they liked the toy, but you took it away because of that behavior. You've removed something good, and they wanted to have it. So hopefully that would help decrease the frequency of them throwing that toy in the future because they lost something that they wanted. So for these 4 different types where we can sort of add or remove things that will either increase or decrease the likelihood of a behavior, these are something that you should probably have a good grasp on. I like asking maybe 1 or more questions about these. Maybe I'll describe a scenario and you'll have to frame it as sort of positive or negative reinforcement or punishment. So this is a good thing to know. There's also some good examples in the textbook. They always run through a bunch of different options so that you can kind of practice and test yourself on some of these. But before we go too much further, I actually want to introduce sort of an addition to this, where we can take our idea of negative reinforcement and actually separate it out into 2 closely related concepts. So our negative reinforcement might include both escape and avoidance behavior. So we'll start with escape behavior because escape behavior is effectively textbook negative reinforcement. Escape behavior is when you perform a behavior and it terminates an aversive stimulus. So the aversive stimulus is that you have a headache. You're going to take an Advil to stop that aversive stimulus. So you escape from the presence of a bad stimulus by doing some kind of action. Avoidance behavior is where it gets really cool. So with avoidance behavior, you would perform a behavior that prevents an aversive stimulus from ever occurring. With our Advil headache example, maybe you keep a very close eye on the weather, and you know that the barometric pressure is going to do something funky, and when it does that, you always get a headache. So the next day before you leave the house, you take a preventative Advil so that even though you always get a headache when the pressure is doing this weird thing, you're covered. You're not going to experience that headache. You avoid that aversive stimulus. When it comes to learning and sort of this setup, especially in, say, operant boxes, avoidance behavior isn't just operant conditioning, because avoidance behavior also requires us to recognize that something is going to happen. So usually we'll set that up using, say, classical conditioning, where the typical way that you study escape and avoidance is in something called a shuttle box. So if you think of, say, 2 operant boxes that are up against one another, and so on one side you would have a stimulus that says, hey, a bad thing is going to happen. So maybe there's a red light, and that red light says that there's going to be a loud sound, or a bad smell, or something scary is going to happen. Until you learn that that light is preceding that bad event, that aversive stimulus, you're not going to react to it. So you need to associate that warning signal with the bad event, with that aversive stimulus. Until you learn that association, you're only capable of escape behavior, where as soon as that aversive stimulus happens, then you would run to the other side of the cage where it's not happening, and you would terminate your exposure to that aversive stimulus. You would escape from the side of the cage that has that aversive stimulus. But once you've learned that that warning signal is giving you sort of a heads up that that's going to happen, you can head to the other side of that shuttle box and avoid experiencing that aversive behavior. You can go to the other side where it isn't dark or smelly or painful or whatever it is that was bad on the other side. So you can classically condition and learn that that sort of warning signal is telling us that something bad is coming, but then you perform an operant behavior by moving to the other side. So avoidance behavior is kind of like that combination of both classical conditioning and operant conditioning to sort of do both at once, which is very cool. And just for sort of ease of remembering and maybe a little bit of good reference material, this diagram here helps us show that breakdown between reinforcement and punishment, and then positive and negative. And they specifically break down our negative reinforcement into escape and avoidance behaviors. So this is just a really nice summary of everything that we covered there. So something good to be able to identify are each of these. And of course, this is about the time where we look at these and say, okay, well, we've talked about 5 different setups. Which one is the best one? Which one is the preferred one to use? And the answer is that it depends. There are a whole bunch of factors to consider. We're going to talk in some general terms. So most of the time, we prefer to use reinforcement over punishment. And for that, the reason why we do that is with reinforcement, we are telling people this is the behavior that we want to happen more often, so they know what to be doing. So that's a good thing, and I'll focus a little bit more on punishment on the next slide. So reinforcement is good for that reason. Specifically, positive reinforcement is usually preferred because there's no ethical concerns about giving someone something good. It's typically a good thing, and you can do something like praise. Praise is great positive reinforcement, and you don't have to worry about, say, using candy or food all the time. So positive reinforcement is a great one. It allows you to sort of tell them what they should be doing, so getting them to do that good behavior more often. We also have this unique outcome where with positive reinforcement and with a lot of reinforcement, you don't have to reinforce every single occurrence of the behavior. So if you are trying to get a child to be nicer to their siblings and you notice that they're being nice and you tell them that they're doing a great job, you don't have to do that every single time they're nice, but if you do it every once in a while, you're going to see an increase in that nice behavior. And we'll actually see that intermittent reinforcement can be very beneficial. But on the other side, it doesn't work the same way. With punishment, it isn't as flexible and it isn't as effective if you don't do it every single time. So reinforcement has a lot of positives to it. If we wanted to focus on the other side of it, we can look at some of the reasons why we don't prefer to use punishment. The first is that punishment on its own doesn't actually teach them what to be doing instead. So if you tell them not to do a bad behavior, they don't know what to do with themselves instead of that. So if a child is yelling for their parents' attention and their parents want them to stop yelling, maybe ask them nicely, but you're only using punishment, you're just telling them not to yell. You're not telling them what else to try. And if they don't know what else to try, then you might not get the behaviors that you want. So you should have punishment plus something to focus them in on the proper behaviors. Punishment also ends up involving aversive stimuli. So we see a lot of issues, especially with positive punishment. So you can have pain or discomfort, things that are not ethical to include in many, many cases. So that's sort of the big thing what we think of with punishment not to use. We also have it affecting more than just the individual receiving the punishment. The person who does the punishing is actually being positively reinforced to punish, if you think about it. So you can frame it as if a parent yells at a child and the child stops doing what they were doing, then the parent might be more likely to yell at the child in the future. So we're seeing more yelling over time. So we frame it as reinforcing for the parent, even if it's positive punishment for the child. And so that can spiral out of control. We can also have the exposure. If someone is on the receiving end of punishment, then they see it as an option to use for others. So if a child is yelled at by a parent, then they might yell at other students and cause problems that way. And then the last point here actually talks about the fact that kind of what I already started on with reinforcement. You don't have to reinforce every single time it happens, but with punishment, it's much less effective if you can't reinforce it every time. It's also, you should be able to reinforce immediately. So every single time, immediately after that bad behavior happens, and with some kind of stimulus, aversive stimulus, large enough that it has an effect. So these are very specific requirements that can't always be met, which makes it a less effective method besides all of the ethical issues that can come with punishment. Okay, and then the last thing I wanted to talk about are these two semi-related concepts of shaping and chaining. So we've been talking about having rats in boxes pressing levers or pigeons pecking keys, but those aren't natural behaviors. Those aren't things that these animals would do on their own spontaneously. We have to get them to do that. So how do you teach a rat to press a lever? Well, the process would be called shaping. And this is when you reinforce successive approximations towards a final response. So if you want a rat to press a lever, you have to start by kind of nudging them in the right direction. So maybe you'll give the rat food anytime they face the lever. Maybe you give them food then when they are closer to the lever, when they approach it, then when they touch it, then when they press it. So those would each be successive approximations. So each of those baby steps towards it would be each reinforced. But specifically, we would use differential reinforcement here because once they've figured out a step, once the rat can face the lever and get food, we would move on so that they no longer get food for just facing it, they'd have to approach it. So you push them or nudge them in that right direction by no longer reinforcing previous approximations. So it's reinforcing successive approximations while not reinforcing the previous ones. So you kind of nudge them in the right direction. That's how we get them to push levers. That's how we get pigeons to peck keys. That's how we get chickadees to hop into a feeder. We sort of shape their behavior. And close to that, we can also talk about the idea of chaining. And this is when you have a behavior that the animal can perform, and instead of immediately reinforcing their behavior, you would give them the opportunity to perform a second behavior. And so maybe instead of just pressing the lever on the left side of the cage, maybe they have to press the lever on the left and then the lever on the right before they get food. So instead of immediately delivering reinforcement, you sort of quote unquote reinforce them by giving them the opportunity to do the second action, which would then get them food. And you can chain together or string together multiple behaviors to get more and more complex actions. So this is a process that would be involved in things like training a pet to do a complex task. So there's some really neat videos of people who train rats to do things. There's one where they have a rat that will carry a ladder up 3 different platforms in order to use it to get across a gap to get food. So that would be a process of chaining where they drag it to the first platform so that they can drag it to the second, so that they can drag it to the third, so that they can cross the gap to get food. So we would frame it as each individual step is reinforcing not because they're getting food, but because it lets them get that one step closer to the action that gets them food. So those are shaping and chaining. And I'm going to cut us off there. We will resume with extinction and other operant-related topics on Wednesday, but we should still be on track to finish up in time for, or we should finish everything by Wednesday at the end of class.